This is question number 5 on section 10.3. The mean waiting time at drive-through of the fast food restaurant from the time an order is placed and the order is received is 86.1 seconds. The manager devises a new drive-through system that he believes will decrease the wait time. So we are saying that H0, the original mean time was 86.1 seconds. Now manager want it to decrease. So he wants to check that if it is less than 86.1. Okay. As a test, he initiates a new system as a restaurant and he selects 10 random orders. So n is 10. And instead of stats in this question, data is given. You see the list of values is given. Okay. Now I wanted to show this question here on the My Math Lab because it uses a little stat crunch. You can do all this on your calculator also, as we talked in the class. You can fill this data. This is only 10 points. You can fill it in stat edit in L1, and then after that you can. Okay, let's read the question first. Because the sample size is small, and as you notice that n is less than 30, we need to check normality because of the second condition. The three verifications. The first verification was random sample, and that is okay. It is random sample. It's given in the question that they selected 10 random orders. Here in the question it's mentioned. But the second condition says if the n is small, if the sample size is small, then you need to check normality. For normality, you have to draw a normal probability plot or the plot between the data and the expected z-scores. This is how that looks. And you can see it's almost in the straight line, right? So because the sample size is small and manager must verify the waiting times in the normal distributed or not. So they show the normal probability plot right here, and the correlation coefficient is also given. R is 0.983. Are the conditions satisfied? So we need to check normality, right? Let's see. For this, here is the critical value table. For 10 values, it's 0.918, and we see that R is more than that. So I think the conditions of normality are satisfied. So we're going to say yes, conditions are satisfied. The normal probability plot is linear enough. It's almost in the straight line. And since the correlation coefficient is more than the critical value, in addition, the box plot does not show any outliers. So we can check that by drawing a box plot in the stat crunch. You can draw the box plot of the data with this. You want it horizontally, and that's about it. So there are no outliers, right? So all these conditions are okay. Check the answer. That's correct. Okay. Is the new system effective? Now that is the question. We already covered that, right? The null hypothesis always is equal to type this, and the alternate hypothesis will also be based upon mean, but we are saying is it decreasing the time of your drive-through order? So it has to be less. Okay. Now the test statistic. In this case, if you're using TI calculator, as I said, enter the data into the list L1 stat edit L1, and then go to stat test at t-test. When you do the t-test, make sure you select data in that case, right? And then fill all the informations. I just want to show here on stat crunch how to use that. So we have our stat crunch open here. I'm going to close this box plot. The data is already here. In stat, there is an option called t-stat. So we are doing the t-stat. There is only one sample, so you're going to select one sample, and data is given in that. So you select data. So one variable which is in our data, Okay, we need to do hypothesis testing. Hypothesis testing is for, okay, our null hypothesis is mu is equal to, correct the value here, 86.1, and alternate hypothesis H is same as H1, it's less than 86.1, right? Okay, and our level of significance we don't really require right now. We can see the critical value also, but that's okay. I'm just gonna compute that. So test statistic is negative 1.8. This is the test statistic here. So that's what we need in our question. So I just want to show how you can use your, it says to two decimal places. So I'm going to write 88 instead of 87 to round it up. Okay, p-value is also given here, 0.0468. Let's see how many decimals, three decimals usually, 0.47. That is your p-value. Now what? So let's go back to our board. It says alpha is given to be zero point 0.1, and you can see the p-value is 0.4047, right? So p-value is clearly less than alpha. That means we are gonna reject H naught. So if you are rejecting H naught, that means you're leaning towards H1. Yeah, you can accept H1, right? So let's see which option is correct. The p-value is greater than, so that obviously is not correct. The second part, the p-value is less than level of significance, yes. So there is sufficient evidence to conclude the new system is effective. So that statement is saying that we are accepting the alternating hypothesis, and which is correct. So I think it's B. So let's try reading the C and D too. The p-value is greater, so clearly that's wrong. The p-value is less than the level of significance, so there is not sufficient. So in the fourth one, they're saying we are rejecting H1, which we are not doing that. We are accepting H1 in this case. So B is the correct answer. Okay, this is question number 5. I hope it helps.